All right, problem 2 off the Spring 16 Math 213 final exam. This problem was pretty hard. It didn't go very well for students, so take that with a grain of salt when you're watching these solutions. Take this problem with a grain of salt. What I'm asked to do is find the volume of a pyramid whose base is a regular hexagon and has side lengths 2 on the base, and the slant height of this thing is also 2. So first off, you need to know that the volume of any pyramid is 1/3 times the area of the base times the height. And that's because we can take three very special pyramids, and kind of put them together to form a cube. And the volume of a cube is the area of the base times the height, so 1/3 of that would be each of the pyramids. But that was just for one special pyramid, but then we kind of made some argument, the deck of cards argument in class, of why that works for any pyramid. So anyways, this is what I got to figure out. The area of the base alone is hard to figure out. Maybe I can get there with a picture. Here's a regular, or close enough to regular, hexagon, 6-sided polygon. And if each side length is 2, it turns out that that tells me that this length is 2 as well. The distance from the center to any vertex is 2. How do I know that's true? Well, it kind of refers back to this problem up here when I drew a 6-sided polygon. I remember that this triangle ended up being equilateral. So if the triangle is equilateral, this side length is the same as this side length. I get that this must be equal to 2 right here. So how does that help? Well, I guess I could think about this as 6 triangles, 6 equilateral triangles. So the area of the base will be 6 times the area of one of those triangles. The area of a triangle is 1/2 the base times the height. So I get 6 times 1/2 times the base is 2. The height is a little bit tricky, because to figure out the height, I need to figure out the distance from here to here. Maybe I call that x. But I can use Pythagorean Theorem to figure that out, because I have this right triangle here. So I can say that 2 squared. Nope, sorry. Yeah, I could. Well, okay, let's start over. This side length, which is 1, because it's half of this 2, plus this side length, x, is equal to the length of the hypotenuse, which is 2 squared. So I get that 1 plus x squared is equal to 4. Therefore, x squared is equal to 3. Therefore, x is equal to the square root of 3, plus or minus, but I want lengths to be positive, so it's just square root of 3. So the height in this triangle is the square root of 3. So the area of the base here is 6 times 1/2 times 2. That ends up giving you 6, because 1/2 times 2 is just 1, and 1 times 6 is 6. 6 times the square root of 3, which I will leave as 6 times the square root of 3, although if you really feel like it, you could change that into a decimal approximation. That's not even the answer. Right, that's just the area of the base. When I get up here for my answer, I'll take 1/3 times that number, 6 root 3, and then I still got to figure out what the height of this pyramid is equal to. So I have this pyramid, and I have that the slant height is 2. So the slant height I can think of as the distance from one of these vertices to the top of the pyramid. So imagine that you have, I will try to draw 3-dimensionally, it never goes well. I have this pyramid up here. Something like this is the top up here. And I have the slant height, and actually I think I lied to you a minute ago. The slant height is the distance from here down to here. And if I have that, I want to figure out what the height of the pyramid is. And that ends up giving me a right triangle in there. It's hard to see that right triangle, but I'll redraw it over here. Here is the slant height of that right triangle, which is equal to exactly 2. And that's given in the problem here. And then I got to figure out what's the length of this side right here. Well, the length of that side right there is the same as the distance from here to here, which is the h in the area of the triangle that I figured out below. And so that was equal to the square root of 3. So this right here is equal to root 3. And what I want to figure out is what x must be equal to. Wow. Okay, so I can solve for x here. I know that root 3 squared plus x squared must be equal to 2 squared. The square root of 3 squared is just 3. So 3 plus x squared has to be equal to 4. So x squared has to be equal to 1. So x has to be equal to 1. In other words, the height of this guy is exactly 1. So the volume of this pyramid, 1/3 times 6 gives me 2. 2 times the square root of 3 times 1 is 2 times the square root of 3. And since I'm talking about volume, it's whatever the units are. I don't think I gave any units. So it's these units cubed because we're talking about volume. Yeah, that didn't go very well on the test, but that's how you solve it in case you're curious. All right, this second one, which I think went a lot better than the first one, I am told that I have a cylinder and its surface area, I'm asked to figure out its surface area, and what I know is its height is 2 and its volume is 18 pi. So here is my cylinder, poorly drawn cylinder, and I know that the height is 2, and I have to figure out its surface area, but what I do know is its volume is 18 pi. So the other thing that I will need to figure out is what is the radius of this guy. The volume, think about the volume of this guy as the area of this circle times the height. The volume is equal to the area of a circle, pi r squared, times the height, which is h. But in this case, the height is given to me to be 2, so the volume 18 pi must be equal to pi r squared times 2, the height. So to solve this equation, I got to solve for what r is equal to. If I divide both sides by 2 pi, I get 9 is equal to r squared, and therefore r is equal to 3. So what I am trying to figure out is what is the surface area of a cylinder who has a radius of 3 and a height of 2. Well, I can figure that out because if I'm thinking about a cylinder is kind of made up, its surface area, of 2 circles and 1 rectangle. You can take this rectangle and sort of fold it around so that this edge meets up with this edge, and that would sort of wrap around, and it would make up the surface area of my cylinder. Well, if I know that the radius of my circle is 3, then the area of the 2 circles would be 2, because there's 2 of them, times pi r squared, times pi times r squared. R squared is 9, times 2 is 18, so I get 18 pi. That is the area of the 2 circles, but I still need to worry about the area of this rectangle. Well, its height is given to me to be 2, and the length of this side is exactly the circumference of one of these circles. And the circumference of any circle is 2 times pi times r, and r is equal to 3 in this case. So the circumference is 6 pi. So the area of a rectangle that is 2 by 6 pi is 12 pi. Take this number times this number. So the surface area is equal to 18 pi plus 12 more pi. It's equal to 30 pi. And do I give any units? I just call them units. And since I'm talking about surface area, they're units squared.